Hi everyone. In the last session, we discussed about the various advantages of functions like reusability and modularity, clarity, and debugging. After that, we have seen the syntax of four types of user-defined functions, and we have seen the programs for the first and second kind of user-defined functions. That means we have written the programs using Visual Studio Code to implement without a function without return type and without arguments, and also a function without return type and with arguments. In today's class, we are going to implement the remaining two kind of user-defined functions using Visual Studio Code. Let us go to the Visual Studio Code. Now I'm going to the new program. So here I'm writing function 3.c. Function 3.c. Now here I'm going to implement the program of third kind, program to implement a function with return type and without arguments. Without arguments. Okay. Now I'm writing hash include stdio.h int main opening brace right here. Here I want to explain the important thing is whenever we say without, what does it mean? As I said that the execution of the program starts from the main. Okay. Main is the calling function. So when we call a function from the main, if the function is of type without, that means main is going to call a function with some name whose return type is without and the parameters are it is not going to take any parameters. That means without parameters. The meaning is the main is not going to give anything to the function. So if I say a function without return type and without arguments, in the sense the main is going to call the function without supplying any value as the input to the function, as well as the corresponding called function does not return anything to the main. That is the meaning of writing without return type and without arguments. Whenever we say without arguments and with return type, the meaning is here the main is going to call the function a specified function by supplying some type of parameters. Right? Means it is going to give the input to the called function, and the called function is going to take the input from the main, and upon completion of the that corresponding function, the function is not going to give anything to the main. Without with means it is taking the input from the main, but the function is not giving anything, not returning anything to the main. That's the logic. Now in this program, what we are going to do, we are going to say with return type and without arguments. That means that the main is not going to give any input to the function, but the function is going to return some integer value or anything. Not only integer, it may return float, character, double. So with return type and without arguments means the main is not supplying any input to the called function at the time of calling, but upon completion of the function or the subfunction is going to give some type of value that we call it as with return type to the main. That's the main difference. So when we talk about with means the main is going to give something to the function, as well as upon completion of the subfunction, the function is going to return something to the main. That's the logic. So now we are going to implement a function with the return type and without arguments. Now here you declare the function first. As I said that there are three important things which are associated with the function. The first one is function declaration, or we can say function prototype, and second one is function calling, and third one is function definition. Now, after the opening brace of the main, this is the place where you have to declare the variables as well as the functions. Now here, what the function we are going to define with return type. With means any return type or any data type you can mention. not only int. Here I'm writing int, and you give the name of the function display. And here I am saying that it's not taking any arguments, just I'm keeping empty. Instead of keeping empty, you can also write void. Okay, that is your choice. And we said that this is function declaration. Function declaration. Roughly, I'm writing this. Now you have to do one thing. So by function declaration or by function prototype, we are specifying what type of value it is going to return and what type of arguments it is going to take and what could be the name of the function. Here the name of the function is display and it is not going to take any type of parameters, right? Without parameters, after that it is going to return an integer value. So here one important thing you have to remember is the display is going to return an integer value to the main, right? To store that returned value of the display, we need a variable in the main, right? So that's why you have to declare a variable in the main. Why? Why? Because to store the returned integer value of display, we need a variable of type integer in the main. For that, better to declare the variable like this, integer sum d. Now the calling of the function here I'm going to do is like this. I'm calling the function display, or instead of saying display here, okay, here I'm saying display. See here, display, this is the calling function, right? Or I can say function call, function call. See here, this is the function declaration, right? This is the integer variable. Now here, this is function calling. So when you call this function here, directly the control is jumped from this statement to the function, the definition of the function display. I have not yet defined the display function, but I'm going to define it after the main. Okay. So once the function of the display function is completed, the display function is going to return some value, right? So at this place, we are going to get some value. What type of value? Integer value. To store this value, what you do is you write left side D. So in this case, what happened? This part is called LHS and this part is RHS. This RHS indicates the function calling. First, RHS side is executed. Now it goes to the function definition. Now I'm writing the function definition void display, right? Now what you do is this void display, what it is going to do, it should return, right? It should return the value to whom? Main. So when it wants to should a return type integer value, when it wants to return an integer value, you have to declare an integer variable in display. For that, you take a variable like integer a. Okay. Now, and assume that so we are taking some variable integer a, and here you can directly give a value 10, or I can say you can enter the integer value from the keyboard. So assume that I want to say like this printf enter any value, right? Any value. Here I'm writing slash n. Now scanf percentage d double quotes close comma ampersand a. If you observe this, the statements of the display is like this. So display is going to use some variable a, what the type integer, and how it is going to read the value from the keyboard. To display message, enter any value, it is displaying enter any value. After that, you are giving some value to a. Now this a should be written to whom? Main, right? For that, what I'm going to do is I'm using the statement return a. This is very, very important. Now this upon completion of this function return a means the a value is returned back from here to here. So now what is the RHS value it brought from the display function? A, right? If you give a value 10, that 10 is returned back to RHS part, and this RHS is assigned to D. Now D value how much? 10. So we have to print this D value in the main. You say printf, okay, the value given by display, the value, the value given by display. is percentage d, comma. You can write slash n, comma a, not a, sorry, d. A is given by the display function, but it is stored in d. D belongs to main, a belongs to display, right? Now, finally, every main finally consists of the statement return 0, right? This is the program. Okay, now we will compile it. We will see whether there are any errors. I'm checking the error. Okay, void display. Okay, it is saying void display. Wait, I'm going to check it. Where is the error? Is there? Right. One important thing is here. What is the error you might have identified? The error is here. In the function declaration, I said int display, but in the function display definition, I said here void. Actually, it is not void. I made a mistake here. It is used. You have to write it as integer. Okay. So this is the function declaration. In the function declaration, we are specifying the return type, the name of the function, and the type of the argument. But here there are no arguments. This is function calling, right side. This is function calling, right? So from this point, the control is directly passed to display, and it is taking a value, reading a value, and it is returning a value, right? A value, how much? What is the type of a? Integer. So it is returning integer type of value. For that, before display, you write integer, right? Now we will see. We will once again execute this. Control S. Now you run it. You see, enter any value. Who is asking this enter any value? The display function. Why? Because the control is switched from the main to the display function, right? The display function is asking the value of a. For example, assume that I'm giving value of a as 15. Now this 15 is returned to whom? Main, and it is stored in D, and D is printed in the main. You see here, the value given by display is 15, right? So this is the way of implementing a user-defined function with return type and without arguments. Now I'm going to implement the last type of function with return type and with arguments. So I'm going to change the same program with small modifications. Now, how to implement this? Now, you write everything as same, but the program is to implement a function with return type and with arguments. With arguments. In your system, you can create a new file for each and every program separately. But here, for clear changes, I'm going to write the same program in one file, different programs in one file. Now, let us change the program. How? What is the function here? A function with return type and with arguments. Now, see, this is the return type with return type, okay, and also with arguments. Now, in this function declaration, what I'm going to do is I'm going to say int comma int. Right. Here, as we mentioned in the earlier classes, when we declare or when we go for the function prototype, the type of the arguments is very, very important, but the name of the arguments or the name of the parameters are not important. Here, no need to mention the name of the variables. Just the data type is enough. If you want to mention the variables, no problem. You can mention the name of the variables, but it is optional, right? So this is function declaration. You may ask one doubt, sir, here you are passing two arguments, two integer types. Can you write float? Yes, any type of arguments. You can pass only one argument or two arguments or three arguments of different type. The return type is also not only integer, you can write character, float, double, long, whatever you are, right? Any built-in data type you can specify. That is your choice. But for example, I'm writing only int return type and two integer type of arguments I am specifying. Right. Now, when you consider this, the meaning is here is the main is going to call the display function, right? At the time of calling the display function, it is going to pass two types of data items. Those are of type integer. One is int and int. Means that the display is going to take two inputs of type int from the main, right? After that, after completing the execution of the display is going to return an integer value to the main. That is the logic here. Okay. Now we have to supply two values to the display, and the display is going to return one integer value. And to store the return value, we need a variable in the main. So for that, you take d is one variable. Okay. Not only d, you take another variable a comma b. Why a comma b? You have to pass two inputs to display. For that, I'm here taking AB, and to store the return value from the display, I'm taking D. Right now, after that, in this function calling, D equals to display. Okay, but here you have to pass what you have to pass, A value and B value. Okay, A value and B value. Previously, we don't have values, but here you have to pass A value and B value. Right? See here, instead of writing A, B here, you can also pass the values like this 10 comma 20. You can give the values like this. When you give 10 comma 20, here there is no need to mention AB. Please remember this. Okay. When you mention AB here, you write it as AB. Very, very important thing I want to clear here is the values, whatever you are processing at the time of function calling are known as the arguments. Please remember, right? Whatever the values that you are going to take, what are the variables you are going to take in the function definition are the parameters. What I want to discuss is I want to differentiate what you mean by the arguments and parameters. Parameters are different, arguments are different. Arguments are the values, okay, which are supplied to the function at the time of calling. Whereas the parameters are the one which are declared in the function definition to receive the values which are sent by the main. That is very, very important. Now here you can directly give 10, 20, but I'm going to pass the values like this, A and B, right? A, B. So I'm writing A, B. But here to pass the values of A, B, what you do is you have to enter the values from the keyboard, or directly you can give, but I want to enter the values, right? You do run like this, printf, enter, enter the values of A and B, right? So who is reading the values? Main, scanf, percentage d, percentage d. Here the important thing you have to remember is the work is shared by the main and the display. Ampersand A, ampersand A comma, ampersand B, right? Now, so by using this scanf, we are reading the value of A and value of B. Now here, take this RHS spot. Why I'm writing D equals to, why? Because display is going to return some value, right? So at place of RHS, we are going to get some value. For that, we write left side D, LHS, right? First, this RHS part is executed function calling. Now directly we are switching to this display, right? Now in the function definition, what you have to do is, so there are two values are coming from the main. What is the type of the values which are coming from the main? Integer. Here you have to mention integer, but in the function definition, the only data type is not required. You have to mention the name of the variables or parameters. So here you mention integer A, integer B. You can ask one doubt, sir, we have AB in main, AB in the function in the function definition display. Are both are same? No, those are different. These ABs belongs to this display. These ABs belongs to this main. These ABs in the main are called actual parameters. These ABs in the function definition are formal parameters. Another name for the actual parameters are the arguments. Please remember this, right? Here in the function definition, the name of the variables and data type is must, whereas in the function declaration, only the data type is enough. No need to mention the variable names. Okay. So the naming is done at the time of calling. So in the function definition, we are mentioning the names. Okay, now we are passing a value. First RHS part is executed. From here, we are moving to this, right? A value, this A value, B value pass to this A, this B. Okay, now Now the display has to return something, right? So what it is going to return is, for example, directly I'm saying this, only one statement I'm going to say is return. So what I'm going to do is just I'm writing return a plus b. That's enough. Return a plus b. The meaning of this is the display function is taking a b values from the main and it is adding those two values and it is returning that sum. Display is returning sum, right? When you add two integers, the result also integer. So that's why what type of value it is returning? Integer. So that's why before this we are writing. So it is bringing back the integer at this place. Control is coming back from the display to this place. And here we have some value, RHS value, that is passed to D. And after that, this D value is printed here. Okay, this is the logic, right? Now we will see whether we are going to get the correct output or not, right? Run it. See here, enter the values of A and B. Who is asking these values? Main. Please remember this, main. Main is asking these values. Okay. After taking these two values 10 and 15, main is going to pass these two values to whom? Display. Now the display is going to find the sum and it is going to return back. To whom? Main. To store the return value in the main, what is the variable we are using? D. You see there. The value given by display is 25. It has taken 10, 15 and it is added 10 plus 15, how much? 25. And that 25 is written back to the main and it is stored in the D and D is printed. So this is the way of implementing the various types of user-defined functions. So next we will see a factorial program to find the factorial of a given number. See, whenever you observe these type of functions, what we have done is we have taken some task and we have divided the task into what do you say, different subtasks, and some of the work is done by the main and some of the portion of the work is done by the corresponding user defined function. Here we are going to share the work among the functions. This is very, very important. Now we will see the program to find the factorial of a given number by using user defined functions. So I'm going to convert the same program into four ways, right? Already we know those four different types of functions. Okay, let us see the program. Now go to the new program. Now I'm writing fact f means factorial using functions. Dot C. Okay, now you write program to find the factorial of a given number using functions. I'm using different types of functions, right? Now what do you do? Hash include std io dot h, right? Int main opening brace here. Now, so we have to share the work between the main and user defined functions, right? So the name of the function I want to use is factor. Okay, or you can say factorial. That is your choice. What is the function name we want to use? Factorial. The name of the function is factorial, right? The name of the function is also called function header. Okay. Now, as we discussed, it may be the function without return type, without arguments, say four times. I don't want to repeat again. Now I'm writing like this. Here I'm writing empty parenthesis means without arguments. Okay. Now before here instead of writing empty parenthesis, you can write what I said void. Okay. Now before this again I'm writing void. Okay. Already you know this is function declaration, right? Okay. Now the meaning of this function prototype is main is not giving anything to the factorial and factorial is not returning anything to the main. That's the logic. Okay. Now simply after function declaration, just you write factorial. That's all. You call this. This is function calling. Function calling. right? That's all. Now, the main work is very less. What it is doing? Just it is calling factorial. That's it. Now, factorial is going to do its own work. Upon completion of the factorial function, just it returns the control back to the main without giving any value. Okay, that's the logic. Now, after the block of the main, go for the function definition of factorial void. In the function definition, you have to mention the void return type, and the name of the function is factorial. Okay. Now here no arguments. Here no need to mention the void. Okay, no arguments. Now in the function, user defined function factorial, what you have to do is you have to find out the factorial of a given number. What the logic we have used in earlier programs? Take some variables and find out the factorial. Now I'm writing the way program like I written in previous classes. Integer, I'm taking variable I, another one is f, another one is n, right? You know this. Printf, already we have seen. Enter any number, right? Slash n, right? Read that number, scanf, percentage d, double quotes, quotes, ampersand n, right? Read the number, and you can use while loop or for loop, and you initialize f equals to 1. I'm using for loops, just you write for speed up the program, just I'm using for I equals to 1, I is less than or equals to n, and you know I plus plus, same logic already we have used. Okay, now here what you do is just you say f equals to f into I, f into I. Okay, now we are calculating the factorial in f. Now you printf factorial of percentage d is percentage d, right? Slash n. Now first percentage d is of whom n, second percentage d is of whom f, right? That's all. This is the program. See here, the execution starts from the main. It is function declaration. Now it is calling factorial. Then automatically the control is passed to factorial. Now variables, right? You give some value n 5 and f equals to 1, and you know this is repeated. If you give n equals to 5, what happened? F equals to 1, I equals to 1, 1 is less than or equal to 5. Yes, the condition is true. Then this statement is executed. F equals to f into I means 1 into 1. After this, the control goes back to, sorry, after this, the control goes back to I plus plus. See here, the meaning of execution of this code is same as just by writing opening brace here, and here you just, and here you write this. So without writing opening brace and closing brace also you can execute. For your understanding, I'm writing opening brace and closing brace. As I said that when there is only one statement which belongs to for, no need of using opening brace and closing brace. So that's why here we are not used closing brace, right? Opening and closing brace. Right, now we will see the execution part. Okay, some errors, check the errors, some errors, identify the errors here. Integer I, f, and I, okay. Next, I equals I less than I plus plus. What is the value? Comma n. What is the error you are getting? Factorial. Check the error. So here you one thing. So it is not required, but you write return 0. It says okay. Factorial of percentage d here. Okay, right. So here mistake is there, right? I think you have identified the mistake. See here after printing slash n. So here you have to mention comma here, right? So you identified. I think you identified. You see this. Here you have to mention comma. Comma is missed here, right? Now you run it. Okay, now it is asking enter any number, right? Not anu number, it is any number. So here you write enter any number, right? Any number you can write. Let us execute the program here. Execute the program, run it. See, it is asking any number. Assume that I'm giving 5. Factorial of 5 is 120, right? Factorial of 5 is 120. Now, if you run the program again, if you give 54, factorial of 54 is 0. Why it is giving 0? Why? Because the range is not enough. So instead of using integer, you have to use long integer. That is a simple logic you have to use. Okay. But better to give small numbers. Why? Because we have taken integer data type. That's all. So now I'm going to convert the same program into another type. Okay. What is the second type? Second type I said that without we avoid and with return type. Here I'm writing something like this int. Meaning is the main is going to give integer value to the factorial, right? What it is going to give? It is going to give integer value. For that, okay, declare some value n here. So n has to supply to the factorial. So that's why we are declaring the variable n, and you enter the value here, printf, enter the value of n, means n value is given by main, okay, and it is passed to the factorial. Enter the value of n, right? After that, you say scanf percentage d double quotes close comma ampersand n, right? After this, at the time of function calling factorial, now you pass n value here. You give n value. That's all. This is a small modifications I have done, right? N we are reading here and we are passing to factorial, right? Factorial. Now in the function definition, here what you do is, so one integer is coming from the main. To receive that, you take any variable you can take, x or y, whatever it is, same variable n. Okay, here I'm taking x, or you can take same variable n, but n is, this n belongs to factorial and that n belongs to main. Okay, now see here in the factorial function, already n value is supplied in the form of x to factorial. So here and this n is not required. Okay, this n is not required, right? This n is not required, and these two statements are also not required. I'm removing this. Okay, f equals to 1, everything must be same. But here you write in place of n, you write x, right? The same logic is used here. Now don't print the factorial here. Who has to print the factor? Okay, print the factorial here. Okay, no problem. So value of n is supplied to factorial and it is calculated in the factorial and it is displaying the factorial, right? Here you have to mention not n, here you have to mention x. That's all. This is the some modifications I have done. Once you check it, everything is same, but small changes I have made. Okay. Now run it. It is asking enter the value of a. You give some other input 6, 720, right? We got the answer. See, compared to the previous one, here some of the work is more balancedly distributed here. Previously, nothing is done by the main, but here some work we have assigned to the main. Please read some n value, and that is passed to the factorial. This is the second type of program. Now, how to write this? How to modify the same program of third type? Just third type. What I said with without. With means I'm assuming that I'm writing int here. Without means you remove this. I'm removing this. So the meaning of this function declaration here is At the time of function calling, the main calling calls whom? Factorial. Now, at the time of calling the factorial, the main is not giving any parameters, but the factorial is giving integer, return type is integer, right? It is returning integer to the main. To store that returned value, here I take a variable, assume that I'm taking the variable n, and you remove all those things. Okay? Understood? What I'm doing is, see, it is not giving anything to the factorial. Who is not giving? Main is not giving anything to the factorial, but factorial is giving some integer value on return. To store this return value, I'm using n. Okay. Now here you do one thing. Use assign like this, n equals to. So right side we are calling factorial, but no need of passing anything. So RHS is executed and it returns some value and that is stored in n. Now you have to print n here, where in the main printf, what the value it is going to give? Factorial, right? So here you write factorial. Factorial is percentage d. Factorial is percentage d slash n double quotes close comma comma. You write n. So instead of using n, you can take variable f related names. Okay, but I have used n. Don't worry. Now see, this is the function declaration and this is function calling. First RHS is executed. The control is passed to here factorial. Now we are not passing anything from the main. Remove this. Right now, what the logic here? The logic here is a factorial has to return integer value. Instead of writing void, you write integer, right? Okay. I comma f, who has to take the n value to print factorial itself, and you say f equals to 1. Now here you have to enter the value, printf, enter the value of n here. Okay. Here we are reading the value of n, that is to be and whose factorial we are going to find out. Next you say scanf percentage d double quotes close comma ampersand n, right? Now here you say I equals to 1, I is less than or equals to n, I plus plus, everything is same. Now here instead of printing this printf, just you have to return, right? What you have to return? Return f you have to return. Factorial is stored in f, right? Now we will check it. Once you see the program, I have done some changes. If any errors, that will see. Now run it. It is asking enter the value of n. Again we are writing 5. Factorial is 120, right? We got the correct output. So here I will explain the logic very fastly. Function declaration, right? So don't worry about LHS. First RHS. This means function calling. We are moving to this factorial, right? Now we are declaring the variables f equals to 1. Enter the value of n. Assume that I have entered n value is 5. I equals to 1. 1 is less than or equal to 5. Yes, the condition is true. F equals to f into I means 1 into 1. Okay, we said f equals to 1, no? 1 into 1. Next, after this semicolon, what happened? The control is passed to I plus plus and it is repeated. And when I value becomes 6, 6 is less than or equal to 5, no? In this case, this statement is not executed and returns f. How much? 120. So, from this place, we are moving back, coming back to where at place of this RHS. Now, at place of RHS, we brought 120. That is assigned to whom? N. And that n here is printed. So that's why we are getting output 5, 120. 5 factorial is 120. Now finally we are going to see the last type, into factorial. Again you say int. The meaning of this is the main is calling factorial by supplying some input to integer, and finally as a result factorial is also giving something to the main. So equal contribution, main is giving to the factorial and factorial is giving to the main. Okay, now what you do is you take n here. Okay, now Who is giving to factorial? Main. Now for that you do one thing. Printf, printf, enter the value of n. Okay, value of n. You read some value from the keyboard and give it to factorial. Percentage d double quotes close ampersand n. Right? Now, now in the time of function calling, what do? You pass some value here. N you give. Okay. You are passing n value. Okay. Now to store the return value, we need another variable. Assume that you take that variable is m, and here left side you say it is m. Now you print m here. M, that's all. Means, for example, you are going to give n value 5 to whom factorial function, and it is going to find out 120 factorial 120. That 120 is again brought to the main, and it is stored in the m, and that m is printed here. Okay. Now here return type is integer, but here also you have to mention int. Here you can use any variable. Assume that I'm taking as n. Then when you take n here, is here this n is not required. You remove it. Why? Because n is coming from the main. Now everything is same, but these two statements are not required. Why? Because n is coming from the main, right? And return f. That's all. Now you save it and you run the program. Again, it is asking the value. I'm giving 6. You are getting 720, right? So we have executed how many types of functions? 4 types of functions for simple task, that is finding the factorial of a given number, right? I think it is clear for you. So with this, I'm going to close the session. So thank you for watching.